Hello everyone. In this exercise of SolidWorks, we will understand about the factor of safety for the bolt connections, a bolt connection, and through the shear for analysis in assembly. Okay, we will also see the factor of safety for the parts also. Okay, I'm going file, new, assembly, and this. Okay. I have made two parts. This window comes, this is the assembly window. I am selecting two parts. I have made already two parts I have made for the study. Factor of this plate 1 and this plate comes here. I am not clicking in the graphic area. I am going up in the graph, this one. This is the view head up tool. You will see hide and show item. I am not click. Click on the scroll button. This and this view origin. Click and again go up. And click here and coincide this one. So this part is located at the origin of assembly. Now go in this one and this one. This part is fixed. You will see here there is a F is written. So this part cannot move. Okay. Now in assembly, insert component, I am selecting another component. You can browse this window, same window comes. I am taking another part. This is a factor of safety, and this one. This part here. You can rotate it. There is small window appears here. You can rotate about x-axis, y-axis, z-axis as per your requirement. But I am not rotating it. This one. Now, mat. Before starting the simulation, our part should be fully defined. When this part we are make, this should be fully defined parts. Okay, this is very essential. Okay, next is the mates. I am selecting this face and this face, this one. This is coincidence relation, this one. Now second mate, I am selecting this hole, this one and this one. This is concentric relation. Okay, and third mate, this one, this surface and this surface, coincidence relation. You will see our fully defined mates are there. In order to make the fully defined mates, you have to make 3 mates. Okay, in this way. So our parts are fully defined and the assembly is fully defined. You can see here. This is okay. Now, in order to make a simulation, first this tab section simulation must be there. If you don't have this one, you can go in the up section and add-ins and you can check it, SolidWorks simulation, and okay it, and then it will come in this tab section. Okay, but I have this one, a new study. There are the two things, new study and simulation advisor. If you select simulation advisor, this will advise new user to make how to conduct this study, but I know, so I selecting new study. You give the suppose we are studying factor of safety. Factor of safety. This one. I am giving the name. First, you have to give the name. I am selecting static. This one. This one. First, I have prepared the model. Second, I have given the name of the study, static, and right click, apply the material to parts. I am selecting the material AISI 304. Okay, this one, and apply and close it. This one, or you can see here, apply the material. This is the units in the Newton per millimeter, so megapascal, and the yield strength is 206.807 Newton per millimeter square. Our factor of safety depends upon this stresses also depends upon the more the value of yield strength, more the shear force it will resist. Okay, apply, close it. Note this point. Now second is the fixture. Right click, fix geometry. In order to make the study stable, our part should be this one, is the fix, so that it could not move up under the application of forces. Okay, this one. This I have fixed here part, and I want to again in order to, when I will apply the force, there are chances to slip in the Z direction. So again I am applying one other fixture, roller and slider, this one and this one, select, and this one, this. So it will move only the clockwise. If it moves, it will move in the, it will rotate in the clockwise direction, not will move in the Z direction. Here you will see here bottom. Okay, applied the fixture and connection, right click, bolt. Because in assembly there are more than one part, so we have to connect this by the fastening devices, that are the bolt connections. They are the different bolts here, number of bolt, countersink, this one, and this, the countersink foundation bolt. I am selecting standard bolt here. There are two boxes, one is selecting, and select the upper face, this one, and second box you select this one, select bottom one, corresponding bottom one, this one, and you will see automatically bolt head direction system takes. This is M12 volt. Okay, distributed means it allows the contact faces for the bolt connection to represent a feasible representation. Okay, so you can allow material is this one, you can select it another material or make it custom. In a custom material you select, this is the Young modulus, you can value feed it. If you select the custom, then the Poisson ratio, and this is the thermal expression coefficient you can feed if you select custom material, if you have your own material. Now strength of the data, you will actually, there are the three strengths. Shear force, if the bolt strength is more, it will resist the shear force. It will resist the shear force. There are the three parameters, three types of strength: yield strength, ultimate strength, and the third is the shear strength. Okay, more is the shear, more is the bolt strength, more it will oppose the shear forces. Okay, and this one I am taking this value in the Newton per millimeter square. Preload, I am not providing any preload. Okay, and this parameter, and fix it here because I will take more, and hit the right button. Okay, I am not selected, I am not given the value of this one. You give the value of pitch of the thread 1.25. I am taking the M12 of pitch of 1.25 and threads per millimeter. Hit this for right button. Now again take second one, this box, this one, and bottom one, this one, okay. This and this one. First select the box, this one, first select, and this one. Now this box, first select this box and this one. Okay, same parameter, you will see same parameter here, this one 1.25, 620, this one, bolt distance. And third is the hit right button, again this one, and select the box. First select the box, then bottom one, and same parameter, this one, this value same parameter I am using, this one. Factor of safety is 2. Factor of safety must be more than 1. Okay, in order to break, and hit the right button here. Okay, and cancel it. Now bolts and nut are applied here. This one, bolts and nuts are applied here. Now I have applied, I have given the name, parts material I have applied, this material I have applied the material. You will see ASI 304. Okay, this one. Now bolts I have applied, connection, you give, I have given the connection local interaction. Local interaction automatically system automatically provides the local interaction. Select the component, this one, this one, and find local interaction. This is the local interaction. Yes, do you want to create selected local interaction? Yes, system automatically gives the local interaction. Now there is an external load. What load you apply? Force, this one, select this one, this phase. I am selecting this phase. Okay, but these forces are in multiple direction. You will see here. This is the multiple direction, but I will select in a selected direction, this one and this one. I am selecting here from top plane. I am selecting top plane and this one, last one in under force, this one under normal to plane, this one, and I am taking this 20,000 Newton. Okay, this is the value, but this is going upward, but I want to take it reverse, this one, reverse direction. Symbol, you can increase the symbol size here from here. Suppose you take 300, you can even edit the color from here, this one, and okay, the color will change. Size of the forces symbol will increases, and hit the right button, this one. Now we have given the name, applied the material, connection we applied, and local interaction I have applied, fixture we applied, external load I have applied to 20,000 Newton mesh. Right click, mesh, create mesh. I am coarse and fine mesh. I am increasing this fine size, and if you increase the fine size, the calculation time more and the rates are very precise, and hit the right button, this one. So under the forces, this parts are divided in uniform small fine element sizes, and uniformly divided this. Okay, now we have to run this study. Assembly is simulation. In assembly, go in the run in the study, this one. I have not warning, preload is at least 1 volt, connection is 0. Do you want to continue? Yes. It takes certain time. This one. Okay, suppose this is the stress. If you want, this is the stress value, you will see our stress is going to change from here, right hand side. This chart legend, you will see the yield strength is 2.06 into 10 raised to power 8. Up to here, the stress value is going to change up. This one. Here you will see this gray area. In gray area, you can find you can see the stresses. Our main focus is to find the factor of safety. If you want to study the factor of safety for the parts, you can go from here. Result advisor, new plot, and factor of safety. This one. This click and hit right button. You will see our factor of safety is 0.448. It means this is not a safe product our. Okay, but we have to study the factor of safety for the bolt connection. Okay, how we will study here? So result and define pin bolt check plot here. You can also take from here result advisors, new this one, least connector force, least this one. I am taking from here this one, result option, this one, define pin bolt and check plot here, and hit right button here. You will see our 2 bolts are under critical condition and one is the safe product. Safe. If you see here, please carefully note this thing. These 2 bolts, 1 and 3. 1 and 3 are critical condition. 1 and 3, and this one is okay. So if we want to know the factor of safety for the, if I am clicking here, this, please see. You will see here. This factor of safety 2. Calculated factor of safety 0.1, 0.5. If I select this one, first bolt, you will see factor of safety is less and desired is 2.1. In this one, you can see here. If you see the details, you will see here. This one. And here you select the all bolts and SI system. If I increase it, you will see here. Our first on first volt shear force is this one, 31,665. And second volt shear force, this is second, the shear force on the second volt is showing green color. It means it is 62,000 shear force here. 6,278. But on first volt, that is shear force is 31,000. And on third this one, you will see 31,065 paid. This is, so our these two boards needs to address. Okay, these are the shear forces. If you want to see the factor of safety for the first bolt, you will see here, or this one, you will see factor of safety 2 and calculated factor of safety is where factor of safety is less here. Okay, if I select first one, this one, you will see here, and again here you will see here this and this one. This, our factor of safety of first and third bolt are 0.51. Okay, and third one you will see also 0.51. Now the question is that how you can increase the factor of safety for the bolt. You can modify the factor of safety for the bolt connectors by increasing the strength of the bolt or increasing the shank dia of this one. You can, for example, this is that, or decreasing the force. There are 3 factors. How you can improve the factor of safety for the bolts? You can increase the factor of safety for the bolts by increasing the strength of the bolt, or shank dia you can increase, or reduce this force. Then you can find the safety. This one. Suppose I apply the material for the this is the part material. Suppose here is the counter bolt. This is the counter bolt hold. Or you can decrease, suppose you can decrease the force here. Right click, edit definition. Suppose I decrease the force. Suppose 6,000 I only apply, or 6,000 Newton. Okay, and this one, and again this one. Now you will see there is a warning signal in the results. So you have to give the mesh again. Right click, create mesh, again you made fine size, okay, and again run this study, this one. Yes, it will take time. I have reduced the force here. You will see here, force 6,000. This takes certain time. Now if I again select red and define pin bolt check force, this one, and hit OK, this one. Again, now if I select first nut, you will see factor of safety has been increased. You will see here, this one, this. You will see here bottom calculated F force is 1.70, sir. Earlier is what, 0.51. Okay, if I select first one, it calculated F force, this one is increased. So by decreasing the load, you can increase the factor of safety. There are the 3 factors, and details you study. There is a shear force here. You can study the shear forces here. This one, all bolts, and increase this one. This one. You will see the shear force also decreases here, because this, you will see here shear force on the first bolt, second bolt is safe, and now but this has been shear force decreased. So we conclude this thing in order to increase the factor of safety by design consideration. You can improve 3 things. One is the strength of the bolt. You can increase from here, edit definition, and here you can increase the strength. And second point is decrease the force, decrease the applied force. You can decrease. In this way, you can improve the factor of safety for this. Same for the assembly parts. You can increase the thickness. You can change the material. So these are the factors you can improve the factor of safety in order to resist the more shear force. Okay. I hope you would have enjoyed in my this exercise. You please like, share, and subscribe my this channel. And thank you very much. Okay.